Standard 9, Subject Science and Technology. Lesson number 1, Laws of Motion. Now see the definition of uniform circular motion. When an object moves in a circular path with uniform speed, its motion is called uniform circular motion. Now see the one example. The speed of the tip of the clock is constant, but the direction of its displacement and its velocity is constantly changing. As the tip is moving along a circular path, its motion is called uniform circular motion. Now see the examples of uniform circular motion. Motion of earth around the sun, and motion of moon around the earth, and motion of the electron around the nucleus, and motion of blades of a fan. Try out and think about it. Draw a rectangular path as given in the below. Place the tip of your pencil on the middle of any side of the square path and trace the path. Note how many times you have to change the direction while tracing the complete path. Now repeat this action for pentagonal, hexagonal, octagonal path and note the number of times you have to change the direction. If you increase the number of sides of the polygon and make it infinite, how many times will you have to change the direction? What will be the shape of the path? This shows that as we increase the number of sides, we have to keep changing the direction more and more times, and when we increase the number of sides to infinity, the polygon become a circle. If an object moving along a circular path of radius r takes time t to come back to its starting position, its speed can be determined using the formula given below. Speed equals to circumference upon time. It means v equals to 2 pi r upon t, where r equals to radius of the circle. Now let's try this. Take a circular disc and put a 5 rupee coin at the point along its edge. Make it move around its axis by putting a pin through it. When the disc is moved at the higher speed, the coin will thrown off as shown in the figure. Note the direction in which it is thrown off and repeat the action placing the coin at different position along the edge of the circle and observe the direction in which the coin is thrown off. The coin will be thrown off in the direction of the tangent which is perpendicular to the radius of the disc. Thus, the direction in which it gets thrown off depends on its position at the moment of getting thrown off. It means that as the coin moves along a circular path, the direction of its motion is changing at every point. Now let us see Newton's first law of motion. An object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. Now see the example. When we are traveling by a bus, we experience backward jerk as the bus starts moving from the rest. This is the example of Newton's first law of motion. Now see the explanation of Newton's first law of motion. A body resists change in its state of the rest or of motion due to inertia. When the bus is at rest, inside the bus we are also at rest. As the bus starts moving, the portion of our body which is in contact with the bus acquires velocity. But the upper part of the body tries to remain at rest. As a result, we exert an inertia of rest and get a backward jerk when the bus moves in the forward direction. Newton's second law of motion. The rate of change of momentum is proportional to the applied force, and the change of momentum occurs in the direction of the force. Example of Newton's second law. While catching a ball, cricketer moves his hands backward. This is example of Newton's second law of motion. Now see its explanation. In the act of catching the ball by drawing hands backward, cricketers allows longer time for his hands to stop the ball. By Newton's second law of motion, force applied depend on the rate of change of momentum. Taking larger time to stop the ball ensure a smaller rate of change of momentum. Due to this, cricketer can stop the ball by applying the smaller amount of the force and thereby not hurting his hand. Now see Newton's third law of motion. Every action force has an equal and opposite reaction force which acts simultaneously. Now see the example of Newton's third law. The principles used for the motion of a rocket is based on Newton's third law of motion. When the fuel in the rocket is ignited, it burns as a result of chemical reaction. The exhaust gases escape with force through a small opening at the tail end of the rocket in downward direction. They exert an equal and opposite reaction force on the rocket. It is this reaction force which makes the rocket moves in the forward direction. Thank you.